First on the list is a rather elegant method known as crystallization. Picture a mixture of potassium nitrate and sodium chloride. The key to their separation lies in the difference in their solubility in a solvent. By manipulating temperature, you can dissolve different amounts of each, allowing for their separation as the solution cools and crystals form. Next, imagine trying to obtain pure water from seawater. Sounds impossible, right? Not with distillation. This method purifies liquids that boil without decomposing and contain non-volatile impurities. By boiling the seawater, the water evaporates, leaving behind the salt. The water vapor is then condensed and collected as pure water. But what if the liquids have boiling points that are close to each other, like petrol, diesel and kerosene? Here's where fractional distillation comes into play. This process separates miscible liquids based on their different boiling points. Sublimation, on the other hand, separates solids that sublime or change from a solid to a gas without becoming liquid from a non-volatile solid. Common examples include naphthalene, anthracene, benzoic acid, camphor, ammonium chloride, and iodine. Then there's distillation under reduced pressure, also known as vacuum distillation. This method works wonders for liquids that decompose below their boiling point, like glycerol. Steam distillation serves to separate and purify liquids that are appreciably volatile in steam from non-volatile components of a mixture. This method separates substances like O-nitrophenol and P-nitrophenol. Aniline is also purified by this method. Evaporation is a more straightforward process. Soluble solids can be obtained from their solution by allowing the solvent to vaporize. For instance, salt can be obtained from a salt solution through evaporation. Chromatography, a method proposed by Iswet in 1903, separates substances based on the difference in the rates at which the components of a mixture are adsorbed on a suitable adsorbent. It's used to separate ortho and para-nitrophenol, blue and red dyes, plant pigments and other natural products. Lastly, there's atmolysis, a method used for separating mixtures of gases. It's based on the difference in their rates of diffusion. In summary, the separation of mixtures is a fascinating process that utilizes a variety of methods, each uniquely suited to different types of mixtures. From crystallization to atmolysis, these methods highlight the incredible versatility of chemistry in action. So, the next time you're sipping on a glass of water or filling up your car's tank, remember the science that makes it all possible.